Hello students, in this question we are asked about the dependence of force and velocity and velocity and power. So let's assume that we have a body like this and we are applying a force onto this body. So if you apply that force, this will have some velocity. So there is a change in velocity, that is delta V. So it started from 0 and it had some velocity, gained some velocity. So velocity delta V will be equal to V minus 0, and the time that taken, which is delta time, will be equal to delta t or t. So that is called acceleration. So there is a gained acceleration here. So the relationship is that F equal to m times acceleration. That is a dependence of that. So if you go further, you can see that the change in velocity, that is delta v by delta t, with force will be linear in like this, right? So that the slope of this line is a, right? Slope is the ratio of y axis with respect to x axis will be equal to delta y by delta x, will be equal to acceleration, sorry, m, that will be equal to m, that is a constant. So m value will be equal to the slope of this thing. So depending upon the mass, the acceleration will prevail. Okay, so for the applied force. Now coming to the second part, which is the dependence of force and power. So dependence of force and power. Okay, so what is force, what is power? So power will be equal to force into velocity, that is the power value, right? So force equal to ma, so we can just do that, m times delta v by delta t times v. So here we can just draw the graph, and this is the delta v by delta t, that is the acceleration here, or v itself. So this will be the power. So with the applied power, what happens is that this is proportional to the delta v by delta t. Okay, and the slope of that line will be equal to mv. So it will go like this, and the slope of this line will be equal to mv, m times v. Slope is equal to m times v, that is the momentum. So based on the momentum, this will go up. So you can clearly see that there is a trade-off between force and velocity in here, power. So it could be that you have a body like this and you're applying some force onto this thing. So this could achieve velocity, right? So the force would then decrease, right? The applied force would then decrease, or the applied force remains the same, right? And the velocity would be small, right? That means that power will be equal to delta F times delta V. We can represent it like this. Okay, that is the change in power, delta P. So the power change, the how the trade-off happens is that if you have a power of, let's say, 20 Newton meter per second, that is the power, unit of power. So this is applied. Okay, that means it could either go as 10 Newton times 2 meter per second, or it could go as 2 Newton times 10 meter per second. Okay, this is just optional. Okay, this is the optional. So what happens is that you can clearly see that as the force increases, the force component increases, the velocity component decreases. That means the particle will have smaller velocity, but still there is a prominent force being applied. That is 10 Newton force applied in here, but the velocity remains 2 meter per second. Or it could have a faster speed, right? So that is 10 meter per second, but still the force will then the applied force will remain minimum, that is 2 Newton. Okay, so that is the difference, key difference in this aspect. So that is the trade-off component. Okay, so this is the graph that you require, and we can go in much detail if you want. Like, you can just think like this. You don't have to think in terms of change in velocity. So change in velocity is a constant term, right? That is the change in velocity between the initial and final position. So we can say that the acceleration component, which is a varying component, and velocity component, which is a constant component or a varying component depending upon the time, at an instant will be equivalent in this case. So anyways, with applied power, either velocity is increasing or force is increasing. One of has to increase and the other has to remain the same or go down to accommodate for the higher force or velocity component. So this is a solution and this is a trade-off. And I hope you find the solution useful. Thank you.